Okay, I'm back, and now we want to do another topic. This one's going to be called scientific notation, and this is going to be a way of taking a very, very large number on your paper and squishing it down so that it doesn't take up so much space. Or it can be used if you have a very, very small number, and again, squishing it down so it doesn't take up so much space on your piece of paper. Now, we've already done this by using the metric prefixes like centi and kilo. So those were ways of taking a number that had a whole bunch of zeros and then making it smaller by putting a metric prefix on it. But this is another way of doing it called scientific notation. Now there's going to be 4 different things that you need to be able to do with scientific notation. So number 1 is, let's say that you have a very big number. So let's say that it's 3, 7, and then 0, 0, 0, 0, 0, 0. And what we want to do is turn this into scientific notation so that it doesn't take up so much space. So in normal scientific notation, standard scientific notation, you always want to put the decimal point after the first number. Now there's nothing really special about where you put the decimal point, but in standard scientific notation you always put it after the very first number there. So we're going to say that this is going to be 3.7 times 10. Okay, now we need to figure out what number goes here, and so we're going to count decimal places. And so don't count zeros because you can get into trouble if you do that. So here's where the decimal point used to be. Here's where we want to put it. So we're going to go over 1, 2, 3, 4, 5, 6, 7 places so that this is going to be 3.7 times 10 to the 7th power. Okay, now we want to be able to go backwards as well. So what if you had a number, now let's say that it was 20.8 times 10 to the 5th power. And we want to change this into regular notation. So this is scientific notation, and then the regular notation is going to be with all the zeros in there. So what are we going to do? So we're going to write down 20.8. Okay, now we need to put some zeros. Now, is this a big number or is it a small number? So this is going to be a big number. Anytime that this thing is a positive number, it's going to be big. So that means that we need, when we put our extra zeros on there, where do we need to put them? So we could either put them over here or we could put them over here. So which side do we put them on? We're going to put them over here. And what I tend to do is I put more zeros than what I think I'm going to use. And then at the end, I can always erase it. So I'm going to need 5 spaces. Here's where the decimal point used to be. And I'm going to move it 1, 2, 3, 4, 5 places. So I'm moving it over to here. And then I can get out my eraser and I can get rid of these extra 2 zeros. And then I can also get rid of this thing. And then finally I can get rid of that thing. And so there is my final answer. So you should be able to take a number in regular notation, change it to scientific notation, or given scientific notation, change it to a regular number. Okay, now what about though if we had a very small number? What are we going to do? So this time, let me write down for you a small number, and we're going to change it to scientific notation. So let's say that the number was 0.000015, and we want to change that into scientific notation. So we want to put the decimal point after the first number, so that's going to be 1.5 okay, and then it's going to be times 10. All right, now we need to move the decimal point, so here's where it used to be, and I'm going to move it 1, 2, 3, 4, 5 places, so my answer is 1.5 times 10 to the 5th, right? No. So this is a small number. This would mean it's a big number, so we put a negative sign on there, and now it's a small number. So 1.5 times 10 to the negative 5th power. Now, what about if you wanted to make it 15 times 10? So now this was standard scientific notation, but what about if we wanted to write it like this? Well, this time we would want to move the decimal point over to here. And so then that means that instead of a negative 5, it would be a negative 6. So both of these are correct numbers. It just depends on where you want to put the decimal point. Now we could also go backwards. So what about if your number had been, let's say, 0.5 times 10 to the negative 8th power? What are you going to do? And I'm going to put a 0 over there. Now you don't have to put that 0 there, but it's good form if you do. And it acts like a placeholder. Okay, so how are we going to do this? So we're going to write this as 5, and now we need to put a whole bunch of zeros. Now we could put the zeros on this side, or we could put the zeros on this side over here. So which side are we going to put our zeros? Well, this is a small number because of the negative sign. So that means that I need a whole bunch of zeros on this side over here. Okay, that may not even be enough zeros. We'll find out. So here is where the decimal point used to be located at. Yeah. And now I need to move it 8 places. So I'm going to move it 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I'm going to put it right there. Okay, now I get out my eraser and I can erase this, and then I can put an extra 0 over here. So that's just holding that decimal point, and so then that would be my answer. So notice that there are 4 different things that you can do with scientific notation. Take a regular number that is big, convert it to scientific notation, take scientific notation, turn it back into a big number, and then this is the 2 things that you can do with the small numbers. So now, if you want, you can go back to any of these charts, typical lengths, typical time spans, typical masses, and now you should understand what that notation over there means. So that's now going to be given to you in scientific notation. All right, let's take a break, and when we come back, we will talk about significant figures.